Okay. Okay, so let's get started with the actual content. And as I said before, today is mostly going to be introduction. Okay, so I have some slides, but then after the break, I'll switch to the whiteboard. So I want to start with a couple of simple questions for you. Like, so the first is, can you identify the cat in this picture? C. Is there a different answer? So does everyone agree that it is C? Okay, so now let's try to do another task. Like, so can you compute this multiplication mentally? Some people can, by the way. So is there anyone in the class who can compute this mentally? People who have done mental math in their cool days. My sister can do this actually. So she did mental math and she can do complex multiplication and division adjustment. I guess most of you cannot. I cannot, right? So we looked at two kinds of tasks, right? Like, so interestingly, the task one that I showed you, right, like just identifying the cat, is too easy for humans. Like, so in a fraction of a second, you can say what is like which one of that is a cat, right? Like, so, but not for missions. It is a really hard task for missions. Okay. On the other hand, task two, the mental calculation, right? Like, so it's too easy for missions. Like, you can give 1,000-digit matrix, like 1,000-digit multiplication, you will get answers in fraction of a second with your computer or even a calculator, right? Like, so, but it's not easy for humans. Why is this the case? So why is it that task one is easy for humans but not for missions, but task two is easy for missions but not for humans? Yeah. Okay. Okay, so task two has exact steps to follow. Task one doesn't. Any other answers? Yeah. Multiplication always gives same answer, but even for this particular question, the answer is always same. Yeah, but given the question, there's only one answer, right? Any other thoughts? Yeah.
But for task one, you need to judge, like judge the picture, whereas the other you just apply mathematical.
Okay, so task two is mathematical. Task one requires something more than being exactly precise or mathematical. Okay, I think these are all similar answers, right? Like, so the real answer here is we know, as you said, like rightly, like we know the exact algorithm for task two, right? There is a precise algorithm for multiplication of two numbers, and you could implement this as a program and just execute the program. The computer is going to give you the answer in a fraction of a second, right? However, we still don't know the exact algorithm that human brain uses to identify cat. Okay, so this is the problem. So if you know the exact algorithm, you can just go ahead, implement it, ask computers to do it. When you don't know the exact algorithms, so what can we do, right? So, well, we have to solve the problem, right? Like, so like we don't want to not solve it because we don't know the algorithm, right? Like, so this is where this philosophy of machine learning comes in. Like, so can we design an algorithm that can find the algorithm to solve a task by just looking at examples? Okay, so in some sense, I want to learn the algorithm because I don't know the algorithm, like myself. I want to learn the algorithm just through examples. Or I want the machine to learn the algorithm by just through examples. I'm going to give a bunch of examples for cats and a bunch of examples for tigers and teach the system that, oh, these are cats, these are tigers, okay? And I want this system to figure out an algorithm which will take a picture as input and decide whether this is a cat or a tiger. Is that clear? So that is the whole essence of machine learning. Now, this question of designing learning systems is not new. So Alan Turing, who is considered to be the father of modern computer science, so he asked this question in his seminal paper in 1950, which is, by the way, the reading for this week. I highly encourage that you go read the paper, which asked this question: can machines think? Okay. Remember, there was no computer in 1950. So the very first general purpose computer was designed, I guess, sometime around 1950, 52, 53, 54, okay? Even that is no way close to the kind of computers that we have right now, right? These are almost computing engines, which does some basic calculations, right? So there was no state-of-the-art computer in 1950, but Alan Turing was interested in designing systems that can actually think like humans. Or he was just considering this question: can machines really think? The paper is very philosophical, you should go and read it. And this paper actually proposed a test to decide whether systems can think like humans. Okay, so he called it imitation game, and we call it Turing test now. So the test is really simple. We're going to put a human tester who is going to ask some questions. Okay, and there are two rooms. One room has a machine that is answering the questions, and the other room has humans who are responding to the question. Okay, now to avoid any biases, the whole conversation is going to happen through text, through typing. Okay, so because we we don't want the voice to be the reason for discrimination. So the tester is going to type his question, and he's going to get a response, typed response from the machine or from the human. And after a few rounds of interaction, the tester is asked to basically tell which room has the human, which room has the machine. Okay. So if he fails for a certain percentage of times, like fraction of times, like to figure out which is human, which is machine, then the machine has won this Turing test. Is that clear? Of course, this test has a lot of flaws, even though people celebrate this test in AI. With ChatGPT kind of systems, now we know that this is not the true test for intelligence. So we right now have a lot of systems which can pass Turing test, okay, but they are not truly intelligent. So we should take this test with a grain of salt, but still, it served its purpose in the sense, for the last 50 years, people were really motivated by this test to design systems that would actually solve Turing test. Okay, so he posed the test, and he also had his prediction, just like how people have AGI timeline predictions nowadays, right? So he had his AGI timeline prediction, in 1950. So the prediction says, I believe that in about 50 years' time, which is 2000, right? It will be possible to program computers with a storage capacity of about 10 power 9, which is a joke now, and to make them play the imitation game so well that an average interrogator will not have more than 70% chance of making the right identification after 5 minutes of questioning. Okay, so the original question, can machines think, I believe to be too meaningless to deserve discussion. So he was way more optimistic about the computer science researchers. So he thought we would solve AI in 50 years. By 2000, this question itself is meaningless, right? But it's not true, but we have made significant amount of progress. Okay, so we're going to see in this course that we have made really significant amount of progress in the last 75 years, especially in the last 5 years. Okay, so the progress in the last 5 years is way more than what we have achieved in the last 70 years. Okay, so we are making progress, but I want to highlight that we are nowhere close to designing systems that has true intelligence like humans. Okay, so you might see a lot of people claiming that we're going to get AGI in 2 years, 5 years, 10 years. I don't think we will have figured out the principles of intelligence in the next 50 to 100 years. Like, so it's so complex. Like, and we are making some progress, but we have not made significant progress. Okay, this is something that I want you to appreciate by the end of this course. Like, so I don't want you to be one of those people going out and say, oh, we're going to get AGI in 2 years. Okay, so achieving true intelligence is really hard. So we still haven't figured out much about how human brain works or like how human intelligence works. Okay, so you might think ChatGPT is impressive, but in reality, it is not. Okay, so it can do a lot of interesting things, but in the end, it is still some sort of glorified pattern matching system. Well, sometimes people argue that humans are pattern matching systems too, but I think we have ways to do deep reasoning and ways to acquire knowledge in a way that it is going to be useful for us in the future. And humans are continual learners. So we learn every day, right? Like, so we improve ourselves every day. We don't have machine learning systems which has this capability. Okay, so there's a long way to go, like before we reach true intelligence. Okay, so well, every year I show this picture, like I show this video to the class. Like, let's listen to the snippet and then we'll talk about it.
Open the pod bay doors, please, Hal. Open the pod bay doors, please, Hal.
The audio.
Hello, Hal, do you read me?
Okay, if you listen carefully, I think you can hear.
Hello, Hal, do you read me? Do you read me, Hal? Do you read me, Hal?
The caption is not working.
Hello, Hal, do you read me? Hello, Hal, do you read me? Do you read me, Hal?
Affirmative, Dave. I read you.
Open the pod bay doors, Hal.
I'm sorry, Dave. I'm afraid I can't do that.
What's the problem?
I think you know what the problem is just as well as I do.
What are you talking about, Hal?
This mission is too important for me to allow you to jeopardize it.
I don't know what you're talking about, Hal.
I know that you and Frank were planning to disconnect me, and I'm afraid that's something I cannot allow to happen.
Also,
Where the hell did you get that idea, Hal?
Dave, although you took very thorough precautions in the pod against my hearing you, I could see your lips move.
All right, Hal. I'll go in through the emergency airlock.
Without your space helmet, Dave, you're going to find that rather difficult.
Hal, I won't argue with you anymore. Open the doors.
Dave, this conversation can serve no purpose anymore. Goodbye.
Hal? Hal? Hal?
Okay, well, I'm sorry. Check. Okay, the audio was probably not good for everyone. Maybe at least in the front. I don't know if you listened to it a little bit. But how many of you have watched this movie? 2001: A Space Odyssey. Just a few. Well, just two or three people. Okay, so this was a movie from 1968. Okay, so again, like way too ahead of its time, like in terms of science fiction. Like so this movie showcased this super intelligent system called, well, they just show the eye of the system. So called HAL. Okay, so this system was put together with a couple of astronauts in a space mission. Okay, so the astronauts the system went rogue, some malfunctioning, and the system went rogue. Like so it started doing things that it should not do. and astronauts wanted to dismantle the system. It basically figured out that they are trying to dismantle just by lip reading, okay, like listening to what they, like just reading their lips on what they're discussing. And I think eventually it will kill all the astronauts. Like, so it will make sure that, like, for example, in this case, like, it basically says, oh, you cannot come in now, like, because your helmet is inside. And if you want to go out and come through the other path, like, so you would die, right? So the point of this video is to show the complex reasoning that HAL has, right? Like, so it has a lot of features, like, so which we would consider to be desirable in a truly intelligent artificial system, right? It's kind of impressive that a director from 1968 had this like really nice view or on what kind of capabilities that we could have. Again, the movie was about something happening in 2001. Okay, so like I don't think we had such a system in 2001, like, but nevertheless, I think this is a very interesting conversation between a human and an agent, right? Like, so it shows the kind of complex reasoning skills, computer vision skills, like, or the knowledge that a system should develop to have this level of conversation, right? Like, so I think we are getting there, but there is a lot of work to be done on the way. Now, so what can a machine actually do right now? Okay, so we talked about the future. We talked about designing truly intelligent systems, right? Like, what can a machine do right now? So I want to give a very quick overview of like the history of like different successes that happen in machine learning. Okay, so like one of the earliest success was, well, I think there were even success stories before this, like, so, but one of the earliest success like that people celebrate is IBM's Deep Blue system, which won the human chess champion at the time, Gary Kasparov, on a match like in 1997. Okay, this system, by the way, was not using anything machine learning, so it was pure search, which is another classical technique for doing AI. Okay, but it was still really impressive that like in 97 you can develop a scalable search-based system that could beat the human chess champion. Okay, and so here is another video from 2004 from Stanford, where a group of researchers in Stanford trained a reinforcement learning system to basically drive the network. So I think the video audio doesn't matter here. So you can see the helicopter doing a lot of complex things, like, and it has learned all these things by itself. Nobody was teaching the system how to do this. Okay, so it has figured out a bunch of maneuvers, and it even does like a bottom-up flying, like, which I think humans cannot do easily, I guess. Like, but the mission has figured out how to do it. Okay, so it does a lot of crazy things, like, and this was like grand success of like training systems from scratch to do really complex control behaviors. And here is IBM's Watson playing
The Russian
Jeopardy at
ballerina's London
2011.
home,
Daily
Ivy
Double.
House, was famous for its ornamental lake with swans. Watson?
Who is Anna Pavlova?
Good for 1600. You're very good in the pronunciations today. Choose again.
Ballet dancers for 1200.
Answer is Daily Double. All right, you have quite a large lead over our two human players. How much would you like to wager?
I'll wager $6,700.
Well, all right then, $6,700. Here's your clue. He was born in Kiev around 1889 to parents who were celebrated dancers from Poland.
Who is Vasyl Nijinsky?
So here you see the internal. Okay, so here you see the internal working of Watson, right? Like, so given a question, again, most of Watson's backend was a bit of search over Wikipedia and other things, and there was a bit of learning involved, and there was also a bit of oral involved in the decision-making side. Like, so for example, like it was betting 6,700. The humans would typically do 2,000, 3,000, like so we will do whole numbers, like we would not often bet 6,700 or 4,569, right? Like so it was making these unusual bets because it was doing some decision making in the end, in the back end. And so here you see the predictions of the system. And in fact, in this case, it is actually making the right prediction. Okay. And it actually won the game against all the humans in 2011. So then in 2013, like DeepMind came up with Deep Q Learning Agent, which for the first time in the entirety of reinforcement learning research, like what they were able to train a system that could actually solve really complex video games, like by learning from scratch, by just looking at the videos. Okay, so just like how humans learn by looking at the screen and learning to play, right? Like so these systems really just looked at the screen and started playing. So you see that initially it is really bad in playing Breakout, right? Like so it fails a lot, right? Now, just after, sorry. So just after, yeah. So just after 10 minutes of training, it is already starting to do something decent, okay? And after 30 minutes of training, it becomes almost professional in solving this game, okay? So, so why does it? Yeah, after 120 minutes, it plays like an expert. So you see that it is really good in playing the game. And after 240 minutes, it actually figures out the strategy, which often humans do, which is basically to make a tunnel and send the ball to the tunnel so that from the top, like you can just easily like finish the game, right? So you see that it makes a tunnel and then like it solves the game in a more efficient way, just like how humans come up with these kind of strategies, right? And the nice thing is the agent is figuring out this just by itself, no supervision, okay? So then in 2016, like so AlphaGo, game from Google DeepMind, like it was beating Lee et al. Like so then Go chess champion, which was a grand demonstration of what machine learning can do. Okay, now, well, how many of you have played Go? How many of you have played chess? A lot of you have played chess, right? Like so, if you have played chess, Go is way more complicated in terms of strategies and chess because the branching factor in Go is huge. Okay, so for several decades, Go was considered to be the hallmark of intelligence in AI community. Like so, like there were people spending their career trying to develop AI agents that could beat humans in Go. Okay, so it is such a hard game in terms of coming up with strategies because the board could look like you're winning, just one move would completely reverse the board, unlike chess. Okay, so well, of course, chess might have such strategies too, but like it's more common in Go. Okay, so when AlphaGo was beating Lee et al. Like in 2016, like nobody believed that AI could actually do it. And what was even more interesting is it made a move in one of these matches, which was completely unconventional, like which threw away all the people who are doing commentaries. Like people just did not know why this move was made. So now that move is celebrated and people are studying that move, like figuring out like why mission made that move, right? Like, so it kind of opened out new non-human strategies, like so that now humans can pick, right? Like now, especially in chess, it has become very common for grandmasters to practice with AI. Like so people do their chess training with AI because AI is so good in chess now. Like so like people train with AI. And I'm pretty sure that's what people are doing in Go as well right now. Okay, so a lot of these competitive games, we have machine learning systems that are really good that people could get trained with these systems. Okay, and I think after that, like I think we had a bunch of interesting things. Like so, one of the things I want to highlight is Like we got really better in image generation. Well, we got two better than 2022 now, like, but this is 2022, okay? In 2022, when you can just type something like a Renaissance painting of a person sitting in an office cubicle typing on keyboard stressed, the system can generate such a painting, even though that painting doesn't exist at all, right? Like, so what is nice about this example is it puts together a bunch of features which are usually very unusual, and the system still gets it and makes this painting, right? But now we have two good systems to do these things. And so I think this is not impressive for 2025, right? Well, I'm not going to play this video. So I usually play this video of what was reality in 2022. The audio is so bad. I don't know if you would enjoy the video. Maybe let's try.
Open the pod bay doors, please, Hal.
Searching for cod recipes online.
Open the doors, please, Hal.
Okay, there is
Searching for cod recipes online.
Open the pod bay doors, please, Hal.
Sorry, I can't find anyone named Rod K. More in your contacts.
Open the pod bay doors, Hal.
Sorry, I'm having trouble processing your request.
What's the problem?
Problem Child is a 1990 comedy movie starring Michael Oliver,
What are you talking about, Hal?
playing Talking Heads on Spotify.
So I had this video in my 2022 class because that was the state of the art. Like, so if you have interacted with like Amazon Alexa or any other like systems like this, like Google Home, so you would find them to be not very good, like in 2022. Okay, but then something happened in 2022. Like, so end of 2022, basically, OpenAI introduced ChatGPT, which was the most impressive milestone like of that time, right? Like, so how many, well, I'm pretty sure everyone has used ChatGPT here. Is there anyone in the class who has not used ChatGPT? No one. Okay. So, well, maybe then I don't need to show you a demo, but nevertheless, I think you can ask really complex things to ChatGPT, right? Like, and it is going to do it for you, right? Like, so for example, I'm going to ask to prove the convergence of this video. Okay. Which you should not do for your assignments, by the way. Okay, so don't use ChatGPT to get answers for the theory questions in your assignments. So in this case, it's actually thinking, because this is a thinking model, and it's going to give you pretty reasonable convergence. This is an easy question. Okay, so let's see what it says. It takes too much time for this simple question. Well, let's just skip the thinking. Okay. So, well, you see that it gives you a proof, right? Like, so, which includes LaTeX as well. And I don't want to verify it now, but I'm pretty sure that this is an easy question where the proof will not have any mistakes, okay? But here is the most important thing. If you really want to use ChatGPT for this kind of application, right? You should not ask any questions that you cannot verify. Simple rule. Okay, so if you cannot verify the proof, you have to be careful with what ChatGPT is giving you, because these models can still make mistakes. They hallucinate. They make really subtle mistakes in the proof, which doesn't make sense at all. And if you are not an expert, you're going to trust the proof and learn from it and learn a bad proof, right? Like, so in general, use any of these applications like ChatGPT for tasks where you can actually verify the correctness. For example, you might be looking for a program. You can view the specifications of the program. It's going to give you the code. You run the code, you can test the code, and you can make sure that the specifications are met, right? If there's a way to verify, then you can trust whatever answer these chat systems are giving you, right? Like, so if there's no way to verify, you ask an open-ended question where you don't have the necessary expertise to validate the answer, right? So then you should not trust these answers. Okay. Okay, so I'll go back here. Well, this was 2022, right? Like, so I don't even have slides for 22 to 25 because now we see nice things happening every week or every day. So there are a lot of AI applications like where people are coming up with new cool video generation models, image generation models, text generation models, like anything that you name, right? But there are a lot of practical applications that we could do. Okay, so speech recognition, language translation, medical analysis, drug discovery, recommender systems, financial applications, including stock trading, having good personal AI assistants, right? Like so robotics, self-driving cars, and even finding new planets. Okay, so at this point, I cannot think of a field which will not benefit from AI and machine learning. Okay, so we are seeing the application of machine learning in almost all the fields that exist, including all the basic sciences: physics, chemistry, biology, medicine, mathematics. And interestingly, like both the biology Nobel Prize and physics Nobel Prize for last year, I don't know if it was last year or this year, the most recent Nobel Prize was given to AI and machine learning researchers. Okay, so which is a surprise even for machine learning researchers, because machine learning researchers used to think that there's no way machine learning people can get Nobel Prize. Nobel Prize is for physics, chemistry, medicine, philosophy, and other things, right? Like so in computer science, like we have Turing Award, which is considered to be the Nobel Prize of computer science. Okay, so but it was a shock for people that, for example, Hinton got a Nobel Prize in physics for his AI contributions. Okay, and DeepMind got Nobel Prize in biology for AlphaFold, which was a protein folding model that they invented a couple of years back. Okay, so this kind of shows how mainstream machine learning is. So it touches almost every field. Like one of the notable advances that I would like to highlight is like yet another recent discovery from DeepMind, like so where they trained a system which invented like a slightly more efficient way of doing matrix multiplication. Right? So for decades, people use the same algorithm for doing matrix multiplication, like the most efficient one. Okay, and DeepMind's agent, oral agent, was able to figure out a small twist in the classical algorithm, which people criticize as not a major improvement because it's just a little bit of improvement. But if you think about the number of matrix multiplications that we do per day, matrix multiplication is everywhere. So even a 0.05% improvement in efficiency for matrix multiplication would save huge amount of electricity, has huge environmental benefit because you will save a lot of compute, okay? But what is interesting for me is not the algorithm itself, but after a week, just after a week, a group of mathematicians analyzed this algorithm and they figured out an even more efficient way to do matrix multiplication, okay? And their success is just because of the agent. So because typically humans don't think in this way, like, so somehow when humans work together with artificial systems, we can explore things that are not very conventional, right? Like, so like machines don't have the biases that humans have. So they could open up paths that are very unconventional. And this is especially true for drug discovery. So in my lab, we do a lot of work in drug discovery, and there are many research groups working in drug discovery. And typically, the way in which drug discovery is done, until even today, is every pharma company has a bunch of biology researchers who use their domain expertise to come up with drug combinations and figure out, oh, whether this is helping cure cancer or not, for example, right? This just works by human experimentation. Now, what we are trying to do is to replace, well, not exactly replace, but like come up with artificial scientists, like which would come up with new drug combinations by reading the entire literature, right? Like, so by the way, a single human cannot read 10,000 research articles in the space of drug discovery, but a machine can do it overnight. Okay, so that's really the benefit of having a machine like which can understand things by reading and coming up with new combinations, right? Like so the hope is we will develop systems that would come up with new ways of thinking about drug discovery problem itself, like new kinds of drugs, which typically humans would not even think about, like when they're making these discoveries, right? So there is a lot of scope in almost every field to do machine learning. So I think I will stop the introduction here. So I hope I motivated you enough to learn machine learning. So we're going to get started with the actual content after the break. Let's take a 10-minute break.